Oh my God, we've made it. We're into part 7 of this Regents review. We're looking at the multiple choice, page 1. Let's take a look at the first one, right? You have manufacturer claims that the number of ounces of a beverage dispensed has a mean of 8 ounces, standard deviation of 0.04. To the nearest tenth of a percent, what percent of cups filled by this company's dispenser will be contained between 7.9 and 8.11 ounces? I see this, right? It's a stats question. That means I want to go to my calculator, right? And I'm looking for that normal CDF function. So take a second, right? Second distribution, and then look for normal CDF. Right, when we come back, right, it's going to give you the option to do your lower bound, right, which is going to be your 7.9, your upper bound, which is 8.11. What's your mean? Your mean is 8.0, and then your standard deviation is that 0.04. When you stick all those values in, you press enter once, you press enter again, you're going to have 0.99 0.08 and kind of repeating. What's the one that's close to? 99.1%. And we're on to the next one. Number 2, right? Given that P doesn't equal Q, P equals 1/2 raised to the power of Q. Expressed in logarithmic form is equivalent to. This one's just testing one little thing, right? If I look at this, I can make this super simple because I know, right, I want to try to get the Q by itself, right? And if I want to take, I don't know, basically if I want to find the inverse, right, of this 1/2 to the power of Q, what am I doing to both sides? I'm basically taking the log of base 1/2, right, of both sides, right? So if I do that, right, imagine like I'm doing this at the bottom, log base 1/2 of 1/2 to the power of Q. Well, this right here just basically is an inverse, right? Because you're taking the log base 1/2 of 1/2 becomes 1. The Q pops down. And I don't have to do anything else, right? So Q just equals that log base 1/2 of P. Answer choice number 3, right? Remember, whatever your number is, right, you can always take the log with that base of that number and it becomes the inverse, which is just equal to 1. Moving on, number 3, right, you have the temperature F in degrees Fahrenheit after T hours of a roast put into an oven is given by that equation. What was the temperature of the roast when it was put in the oven? So we're looking for the temperature, right? When the roast was put in the oven, think about that as like your initial value. So what does my T? My T has to equal what? 0, right? So if I substitute this in, I say F equals 325 minus 185 times E to the power of negative 0.4 T, but T is just 0, right? What happens here? This becomes 0. Anything raised to the power of 0 is what? 1. So if I rewrite this, I got 325 minus 185 times 1, which is really just 325 minus 185. What do I get for an answer? 140. Not that bad if you just know to substitute and then also know that anything raised to the power of E or of 0 equals 1. You could also probably put this into your calculator exactly as it is and get that answer too. Number 4, right, the roots of this equation in simplest A plus BI form are, so once again, right, I think we saw this in the last video. I see A plus BI, that means I know I'm most likely going to have an imaginary number, which means I'm going to have a negative number underneath, right, like the radical part of, or the discriminant part of my quadratic formula, right? So I can label, right, x squared, right, over here is still a 1, so that's my A. My B is 6. My C is 10. So I'll do it again one more time. Negative B plus or minus B squared, which is 6 squared, minus 4 times A, which is 1, times C, which is 10. That's all be underneath the square root, and that's a 6 in parentheses all over what? 2 times A. When I do this math, right, I got what? Negative 6. If I put 6 squared minus 4 times 1 times 10 in my calculator, I'm going to have negative 4 all over 2. And this one's a little bit different because this little spot right here, right, I can actually simplify, like, right, what's the square root of 4? It's 2, so if I rewrite it over here, what does it really look like? It looks like I'm saying negative 1 times the square root of 4. This becomes I. This becomes 2. What am I left with? I'm left with negative 6 plus or minus 2I all over 2, right? And then I know when I'm simplifying, right, I got the 2 at the bottom, I have to divide, right, the negative 6 divided by 2, but also the 2I divided by 2. So when I do that, what am I left with? Negative 3 plus or minus I. Is that an answer choice? Yes, it is. Last one. Which equation does not represent an identity, right? So that means, right, there's only one here. 3 work, 1 doesn't work. So I want to look for the ones that I know work right off the bat, right? I'm looking at number 1. Number 1, oh my God, it's a example of difference of perfect squares, right? Because x squared minus y squared is just x plus y, x minus y. That one works. Let's get rid of it. This one, I mean, I feel like I had to bother you guys enough about looking at remembering that x minus y to the power 2 is not x squared minus y squared. It's actually just x minus y times x minus y because you're multiplying what's inside here 2 times. That is an identity, right? It works. It's true. Get rid of it. Now I have 2 more choices, and you know what? I'm just going to keep rolling. I want to keep trying to find true things. This one, x plus y squared, looks exactly like this. So if I rewrite this out, what am I really saying? I'm saying, I'll just do it over here. X plus y times x plus y leaves me with what? X times x, x squared. X times y plus xy. Y times x plus another xy. Y times y plus y squared. X squared plus 2xy plus y squared. This one is also an identity. That means this one right here is the only one that has to be, right, not an identity. And if I looked at it a little bit closer, right, the second you have this, you're doing this 3 times, right, you would be multiplying this, right, because that's x plus y squared times another x plus y. Like, you're going to have a ton more terms. It's not going to look as simple as this. Answer choice number 4 is correct, right? And we did that by basically proving the other ones were correct, right? So sometimes you got to mix and match. Page 1 in the books.